Introducing the Smart Sleeve. This device can turn some of your bodily signals into music that is synced to your reactions. Let us take a closer look at how this system operates to generate your body's tune. It uses the Arduino platform to perform all necessary computations and acquisitions. First, there's the heart rate sensor, which you can strap to your chest. It can catch tiny electrical pulses generated by your heart. It requires a 5-volt power supply provided by the red and black cables, red for 5 volts and black for ground. It sends its signal from the BTA plug to the Arduino through the yellow cable to the analog input A0. Next, there's the GSR sensor. GSR stands for Galvanic Skin Response. It reflects the level of the skin's conductivity. The more you sweat, the more your skin is conductive. Not only that, but it also fires up whenever someone experiences emotional arousal, which could simply happen by taking a deep breath. Just like the heart rate sensor, the GSR requires a 5-volt and ground power supply and outputs through the yellow wire that gets read by the analog pin A1 on the Arduino. As for our third sensor, the accelerometer, it measures the body's acceleration relative to freefall. This means that it can provide us with information that relates to the body's inclination. We use this property to make it count push-up repetitions. How this resolves into music is discussed later. After the adequate processing is done on the Arduino, we use the Pro Tools digital audio workstation on the PC to convert the Arduino output to music. To do this, we use the MIDI communication protocol, which is a standard in the music industry for information transmission. We'll explain what the Arduino outputs in a bit. To connect the Arduino to Pro Tools, we use a 5-pin DIN cable, which also is a standard for MIDI communication. To achieve this, we use a female DIN module. Now, our Smart Sleeve has 2 modes of operation. There's the running mode and there's the push-ups mode. The user can press on the push button connected to the digital pin 7 of the Arduino to toggle between these 2 modes. Let's take a closer look at what the Arduino does on the inside. Here's what the main loop function does at each repetition. The first if statement determines the mode we're in, either push-ups or running. The second if statement does all the necessary computations in the measure heart rate function if we are in running mode, else computations are done in the push-up function. What the measure heart rate function does is that it measures the time interval between 2 pulses for the heart rate sensor and does some averaging on multiple time intervals between different pulses to generate an approximative heart rate. This heart rate is then used to generate a beat at a speed that is equal to that of the heart rate. In parallel, the GSR is monitored for changes at different thresholds. Once one of those thresholds is attained, the mood of the music changes. 3 different music moods or chord progressions are stored in an array. We keep looping in one of those moods until a threshold is reached. At that point, we start looping in another chord progression. The music is generated using 2 functions from the Arduino MIDI library, which are sendNoteOn and sendNoteOff. A note is sustained from the moment sendNoteOn is called until sendNoteOff is called. It should be noted that all information relating to the beat is sent on MIDI channel 1 and all harmonic information on channel 2, so that we can assign 2 different instruments on Pro Tools, a kick drum for the beat and a piano for the harmony, for example. Now, considering the push-up mode, the idea is to generate a new chord, which is a set of musically harmonious notes at each push-up. The same array as before is used and no beat is generated. This way, you can create your own rhythm by simply doing push-ups. Let us take a look at what Pro Tools does. After the strap is mounted on your arm, all you need to do is plug the MIDI cable into the computer, create 2 MIDI tracks and 2 instrument tracks on Pro Tools. The MIDI tracks are then linked to the instrument tracks so that when a MIDI signal arrives, a sound is generated. Each MIDI track receives information from either MIDI channel 1 or 2. The MIDI tracks are then linked to the instrument tracks, and there it is! You're good to go!